Hey grade 12s, my name is Victoria Coonan and I'll be teaching you about the manufacturing of ammonia. Let's begin with the basics. What is ammonia? Well, ammonia is a weak base. It has a Kb value of 1.8 times 10 to the negative 5, which we'll come back to later on. And the one thing you may not know is that it's one of the top 5 industrial chemicals in the world. It's hard to believe because you don't usually hear ammonia being used in anything, where in reality, it's used in everyday life. For example, nitric acid can make polymers, explosives, and ammonium nitrate can also produce explosives, as well as fertilizers. But the main reason we should care is ammonia is part of many common household products, such as Windex or detergents. So let's stop here for a moment and analyze the logic. If ammonia can be used to make explosives, as well as used to make something humans handle in their everyday lives, there must be a difference between the two. It's only logical that when ammonia is used in detergents, it's weaker or more dilute than those used in explosives. This is where the base dissociation constant, or Kb value, comes into play. The Kb value is useful when calculating the pH of a substance, as it helps guide the equation to find the concentration of hydroxide or hydrogen atoms to furthermore get how basic or acidic the solution is. So you can only assume that ammonia used in detergents has a more neutral pH than ammonia used in explosives. Some other uses for ammonia can be rubber stabilizers, pharmaceuticals, or refrigeration. Now that you know where ammonia is used, let us now continue to how ammonia is manufactured. The Haber-Bosch process was made by Fritz Haber and Carl Bosch, and the purpose was to find the most efficient way to manufacture ammonia in large quantities and low costs. At equilibrium, the direct synthesis of ammonia is hydrogen gas plus nitrogen gas. And to find the equilibrium constant, all you would need to do is multiply the concentration of the product by its coefficient in the equilibrium equation and divide it by the product of both reactants multiplied together with their coefficients, like so. To help you visualize this process, I'd like to take you through how this machine actually works. You'd begin with nitrogen gas, shown as the pink dot, and hydrogen gas, shown as the blue dot, being put into a very high pressure compressor at a fairly high temperature. High pressure plants are dangerous and very expensive to build, but Carl Bosch found a way to fix this. He built a double-walled steel vessel compressor that was able to operate at 20 to 30,000 atmospheric pressure. This allowed for more ammonia to be produced. The next step is where two gases would enter a chamber filled with catalyst, which helps increase the rate of reaction. Fritz Haber experimented with thousands of catalysts to finally choose the iron catalyst, shown as the red dot. The reason for his choice was because it lasted 5 years before losing effectiveness and worked at high temperatures, which the process was going under. After this step, ammonia, shown as the purple dot, will begin to be produced. As soon as ammonia begins to be produced, it enters a condenser where the temperature is lower. Now let's stop for a moment and take a closer look at ammonia. As you can see, the nitrogen has bonded with 3 hydrogen atoms, and it has 1 lone pair left. We already know that ammonia is a weak base, so it dissociates in water easily. That's because the lone pair can bond with the hydrogen atoms of the water. Now, from the condenser, 2 things are going to happen. The unreacted nitrogen and hydrogen gas will return back to the compressor and be recycled so that they could be processed again, and no reactants will be lost. Another thing that will happen is that the ammonia will become liquid because it has condensed, and it will finally reach its final destination, the storage tank. Now that you know what ammonia is, where it's used, and how it's made, let me tell you the last and final most important thing about manufacturing ammonia. The whole Haber-Bosch process is based on Le Chatelier's principle. Henri Louis Le Chatelier once said that a dynamic equilibrium tends to respond so as to relieve the effect of any change in the conditions that affect the equilibrium. Now you may be thinking, what in the world is he talking about? Well, it's pretty simple in relation to how ammonia is productive. The more nitrogen and hydrogen gas you insert, the more ammonia will be produced. Since the reaction is exothermic, the lower the temperature, the more product will be produced. Now don't get this confused with the Haber-Bosch process, which worked at a high temperature. This was because the rate would be too slow at a low temperature, and the other factors involved still produced enough ammonia to be efficient. Also, increasing the space for the storage of ammonia will increase the product, because you can only fit so many jelly beans into one jar until they start falling out. And lastly, the higher the pressure, as Bosch made the steel vessel tank, the more ammonia can be produced. Thank you for listening, and I hope you learned a lot.